Hey there, science enthusiasts. Today we're diving into the fascinating world of electrical resistance. You can think of it like this. Imagine a bunch of excited electrons zipping through a wire like a bunch of puppies trying to get through a doorway. The wire is like a hallway and resistance is like the rug on the floor. A smooth, clean hallway with no rug, which means low resistance, lets the puppies run wild. But a hallway with a thick, shaggy rug or high resistance slows them down, making it tougher for them to zoom through. Let's break down the key laws that govern how resistance works in conductors. First up, we've got Ohm's law, named after the brilliant physicist Georg Simon Ohm. This law is like the rock star of electrical circuits. It tells us that the voltage, which is the push behind the electrical current, is directly proportional to the current, the flow of electrons, as long as the resistance stays the same. Think of it like a garden hose. The more water pressure you have, or voltage, the more water flows through the hose, or current. But if you squeeze the hose, increasing the resistance, you need more pressure to keep the same amount of water flowing. Ohm's law can be written as a simple equation. V equals I times R. Easy peasy. Now let's talk about the length of a conductor. Imagine you're running a race. A short sprint is a breeze, but a marathon? That's a whole different story. The longer the race or the wire, the more tired you get, or the higher the resistance. That's because the electrons have to travel farther and bump into more atoms along the way, creating more resistance. So, if you double the length of a wire, you double its resistance. Now imagine you're trying to get a crowd of people through a doorway. A narrow doorway creates a bottleneck, right? But a wider doorway lets more people through at once. The same goes for electrical current. A thicker wire has more space for electrons to flow, making it easier for them to get through. So, a thicker wire means less resistance. You know how some materials are just naturally smoother than others? Like sliding down a water slide versus trying to slide down a carpet, big difference? Different materials have different levels of electrical smoothness, which we call resistivity. Copper, for example, is like that awesome water slide. It's a great conductor because it has low resistivity. Rubber, on the other hand, is like that carpet. It's an insulator because it has high resistivity. Last but not least, let's talk about temperature. Think about what happens when you heat up a metal pan. It expands, right? Well, when you heat up a conductor, the atoms inside start vibrating more, making it harder for the electrons to zip through. This means the resistance goes up. It's like trying to run through a crowd that's jumping up and down. Not so easy. And there you have it. Understanding these key laws of resistance is crucial for anyone working with electrical circuits. From designing efficient power grids to building tiny microchips, resistance plays a vital role in our technological world.